All right, this video is about the distance formula and the midpoint formula, specifically in the context of circles. So real quick, let's review what the distance formula and the midpoint formula are. You can see the distance formula up there in the top left. It looks pretty complicated until you realize that it's based on the Pythagorean theorem. So here you have a line segment and its endpoints, and we're going to use the distance formula to show how long that is. So you can see the x coordinates. So from here to here is the difference in the x coordinates, which you can see represented here. So we can do that as 3 minus and negative 3. So really 3 plus 3. And then, of course, we're going to wind up squaring that for reasons we'll see in a second, plus the difference in the y coordinates. So we are there at 3 minus negative 5, which of course is 3 plus 5 squared. And then we're going to take the big square root of that. So you can see we have made a right triangle, and the reason why the distance formula works is because it's based on the Pythagorean theorem. The two red lines there, the differences in the coordinates for x and y are the legs, and the line segment itself that we're trying to find the length of is the hypotenuse. And so that's why we are squaring, summing up, and then taking the square root. So this here is 6 squared, which is 36. This is 8 squared, which is 64. And we're going to take the square root of that sum, which is the square root of 100. So this, the length of this line segment is 10 units long. That's the distance formula. So if the distance formula is based on the Pythagorean theorem, the midpoint formula is based on averages. We know that to take the average or the arithmetic mean of two numbers, we are going to add them up and then divide by how many numbers there are, in this case 2. So again, you see the same line segment, the same endpoints, and really we're taking the average of the x values and the average of the y values. So we're going to do negative, whoops, excuse me, let me get my pen going here. We're going to do negative 3 plus 3 divided by 2. That's the x's. And then we will do negative 5 plus 3 divided by 2. That will be the y's. Well, negative 3 plus 3 is 0. And negative 5 plus 3 is negative 2. And we divide that by 2 and we get negative 1. So there is our midpoint, which is right there. You can see that right there. So that is the midpoint formula in action. Now, how might we see this in action for circles? Well, here, what is the length of the radius of a circle with a center at negative 1, 2, and passing through the point 4, 6? Well, okay, so the length of the radius, those are the, so that's what we want. We want, oops, excuse me. We are interested in the length, and we have 2 endpoints. So length is distance formula. So the first thing we're going to do is find the difference in the x values. So that's going to be negative 1 minus 4. And we will square that. And then we will have 2 minus 6. And we will square that. There we go. And then we're going to take the square root of all of that. So here we will have negative 1 minus 4. The length of that is negative 5. And we will square that to get 25. And then we will do negative 2 minus 6, which is negative 4. Square that, and we'll get 16. So we have 25 plus 16. We're going to take the square root of that, and this will be the square root of 41. So the square root of 41, sometimes you'll be asked to leave it in radical form. Sometimes you will need to find a decimal for it. It's going to be about 6.4. It really just depends on what your teacher wants. But that is the length of that radius. Second example, the length of the radius given a diameter with endpoints -3, -1, and 5, 7. Well, let's draw this out because I want to make a point about this. So here is a diameter, and we have 2 endpoints, and we want to know the length of the radius. Well, the length of the radius is just going to be half of the length of the diameter. So let's find out how long the diameter is, and then we will divide it by 2 to find the length of the radius. So again, we will do, excuse me, we will do -3 minus 5, which is going to be -8 squared. And then the y's, -1 minus 7, which is also -8 squared. It doesn't matter which order we do them, the x's in or the y's in, because we're just going to wind up squaring that difference anyway. So this is going to be the square root of 64 plus 64, which is 128. And then if we find out, let's see, this is going to be 8 and 8. So the diameter is 8 times the square root of 2. And then if we divide that by 2, our radius is going to be 4 times the square root of 2. And again, if your teacher would rather have a decimal, then adjust. Final example here, what are the coordinates of the center of a circle given a diameter with endpoints -3, -1, and 5, 7? So again, here's our diagram, and the center of a circle is the midpoint of the diameter. We know these two lengths have to be the same. They are radii coming together to make the diameter, but that is the midpoint. So we're going to use the midpoint formula here. So the x's, 5 plus -3 over 2. And the y coordinate is going to be 7 minus -1. So plus plus, also divided by 2. So this winds up being 2 over 2, and this winds up being 8 over 2. So our whoops, excuse me. This winds up being, sorry about that, 7 plus -1. So let's go in and look at this whole happy little accident here. That's going to be 7 minus 1, so that's now going to be 3, or 6. Oops. A little bit of a mess here. There we go. 6 over 2. That's good. Okay, and now that gives us our midpoint as 1, 3. Very good. So, things you have to watch out for. Obviously, when do you add and when do you subtract? That one just caught me. Yes, so just remember, you know, for distance formula, the legs of that right triangle we're making are the differences of the x coordinates and the differences of the y coordinates. And the midpoint theorem is built on addition because it is the arithmetic mean or the average of the x-coordinate and the y-coordinates. All right, thank you very much for watching. I hope this was helpful. You're doing great work. Keep it up. Take care.